Please go to EliTheComputerGuy.com in order to view schematics, code, and more for the projects that you are learning about. Welcome back. So in today's video, I want to talk about client-server architecture in regards to client computing infrastructure. So it is important to understand when I start talking about architectures, whether I'm talking about client-server architecture or service-oriented architecture or serverless architecture, these are methodologies for building out your infrastructure. Don't get too hyper-focused on the specific definitions of this thing, that thing, or the other thing. Basically, this is a way of looking and thinking about how to build your infrastructure, and then from that concept you will then go out and you will pick the technologies and you will pick the specific products in order to build the infrastructure that you think will be good for your organization. A lot of new people, whenever they first get into this and they first start learning about architectures, they think it's 100% one thing or 100% another thing, that basically it's some kind of binary issue. Either you have a service-oriented architecture, or you have a client-server architecture, or you have a serverless architecture. In reality, the fact of the matter is, you're going to have some client-server stuff going on, you're going to have some service-oriented going on, you're going to maybe, possibly, have some serverless going on, and then there's going to be a couple of other architectures out there that'll kind of get mishmashed and all just kind of squeezed together into whatever infrastructure that you have built. So whenever we're talking about these architectures, don't get hyper-focused on any one thing. Basically, this is a methodology. It's a way of thinking about how you're going to be building your infrastructure, so that once you have that idea, you're like, oh, okay, yeah, this is how these things should work together. Then you start figuring out the technologies that will actually allow that to happen, and then you figure out the products that will then implement those technologies to make all of that happen. So we're talking about architectures. This is just methodologies. These are concepts about the ways that your infrastructure should be designed. Don't get too hyper-focused on one specific thing. So with this, when we're talking about client-server architecture, we're talking about an architecture style that's been around for a long time now, and basically this is the standard architecture style that you will have dealt with on your local area network. So if you've been dealing with LAN environments, if you've been dealing with Active Directory environments, if you've been dealing with old school email with Exchange server environments, that's the old client-server architecture. So basically the idea with a client-server architecture is that you have a server. So you have a physical server. That physical server has a server operating system installed on it, and then that operating system has specific services installed on that operating system. So think about Active Directory or Exchange server, FTP server, routing and remote access server, which is the VPN server in the Microsoft world, right? So think about that. Basically, you have a physical server, you have the operating system, a server operating system installed on that physical server, and then on that operating system, then you have services that will then be provided to the clients on the network. And then when you go out to the client computer or the client devices, so a client computer can be a laptop computer, it can be a desktop computer, it can be a laptop computer, it can be a smartphone at this point, who knows, it can be a smartwatch at this point. Basically, you have some computer that's a client computer that then has an application installed on that client computer that is able to communicate back to the server and be able to access the services on the server. So that's why we call it a client-server architecture. You have clients, you have client computers that have an application installed on them that are able to then get services from the server computer. And that's basically how networking has been built for a long time. And so you're going to be dealing with this one way or another for a long time to come. Now, one of the big things that's different about client-server architecture versus some of the other architectures when you're thinking about designing this or when you have to maintain it is that you have to deal with all of the equipment, all the services, all the systems that allow communication to happen between the client computers and the servers. So when you're dealing with some of the other architectures out there, a lot of times you really don't have to worry about the networking, you don't have to worry about firewalls, you don't have to worry about those types of things. That has already been built in into how the communication is supposed to happen. Whereas when you're dealing with client-server architecture, you're going to have to be dealing with everything. So basically, you're going to have a client computer. So that client computer is going to have an operating system on it that you're going to have to make sure that's working properly. Then it's going to have the app or the software on it that's going to be communicating with the server. So you have to make sure that's working properly and that's configured properly. You have to have the server with the server operating system with the server services installed. So again, you'd have a physical server, you'd have, let's say, server 2012, and then you'd have Exchange server. So you'd have to make sure Exchange server and all of those things are configured. Then you have to make sure things such as the firewalls, the ports and the firewalls are open, being able to route traffic from the client computer to the server. You have to make sure that can happen. So if it's internal to your local area network, you have to make sure that the client computer and the servers are on the same subnet, or that there is routing. They're able to be communicated with through routers. If your client computer is actually outside your LAN, so let's say it's a remote worker or something like that, you have to set up the way that that remote worker is actually able to connect back to the server within your environment. So whether that's through something like port forwarding within a firewall, or whether it's setting up a VPN access, right? All of those things have to be considered to make sure that your client-server architecture works how it's supposed to work. In the real world, back in the old days, 13 years ago or so, I was doing some work with a company, and they had a lot of remote workers. And one day they just started getting inundated with help desk calls. Basically, the VPN service was no longer working. So they had a routing a remote access server within their environment, and all their users, their remote users, were able to connect to the internal environment using the VPN to connect to that routing remote access server. Well, a weird thing happened. A quirky thing happened, as they say. Comcast, out of the blue, decided to shut off the VPN port for residential clients. Comcast just one day decided, well, residential clients, they don't need VPN access, so we are simply going to turn off the VPN port. And so when they shut off the VPN port over the Comcast network for the residential clients, all of our remote workers that use Comcast could no longer connect to the VPN server. So they have a VPN client on their system. There's a VPN server that allows them access to the internal network, and then they actually have to communicate over the ISP. Since the ISP decided to shut off that particular port, the service all just stopped working in the blink of an eye, and that was about an amusing week. And so that's something you have to be thinking about with client service architecture, is you're not simply responsible for configuring the service. You're not simply responsible for configuring the client. You're responsible for everything that is required for the clients to be able to communicate with the server and make sure all of that happens. And so that's one of the problems you can run into, is if your ISP just decides, we're going to close a port, then you can run into a lot of major issues. So that's one of the things to really be thinking about when we're talking about the client server architecture, and why this is a little bit different than some of the other architectures. So you may be sitting there thinking, well, if client-server architecture is old and I'm young, so I don't want to deal with old stuff, why would I even bother with client-server architecture anymore? And the reality is you will bother with client-server architecture for the reason all of us deal with incredibly old crap that should have been thrown in the trash years ago. It's called legacy infrastructure. So what legacy infrastructure means is all the crap that was built before you, that basically the executives don't want to replace. Remember, when you're dealing with executives, when you're dealing with managers in your company, they will be willing to spend money, and possibly a lot of money, to get better services, to get better performance, to get something more. They're not going to spend very much money to basically replace exactly what you already have with something else that provides the exact same thing, only the architecture is different. Right, so basically that's one of the big problems is, let's say you coded something way back when in PHP. So you have a lot of code running in PHP. You realize, this would be so much better if it was in Node.js. So you think, hey, I'm going to migrate all the code from PHP to Node.js. You go to the executives and you say, hey, I want to spend this much money migrating the code. And they say, well, why? What additional thing are we going to get by having this written in Node.js versus PHP? And you go, well, it'll be a little bit easier for the coders to know, and it's a modern language, blah, 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 blah. And basically the executives are going to say, so you want us to spend all this money to essentially get exactly what we already have? No, we will spend money on something else. And so that's why you're going to be dealing with client-server architecture for a long time to come, simply because it is a legacy. If you're dealing with large corporations or even medium-sized organizations and companies, the fact of the matter is they already have a client-server architecture. They already have their client computers communicating back most likely with their Microsoft servers. And you're going to keep that going because it is easier to maintain and build off of what has already been built versus trying to start again from square one. So that's one of the reasons why you're going to be dealing with the client server architectures. Now, from that point, though, one of the things you can start doing is you can start thinking about how you can start bringing the cloud into your client server architecture, how you can start migrating some services off onto the cloud and that type of thing. So let's say with email services. So you may have Outlook. So Outlook is installed on your Microsoft client computers, and then you have Exchange Server on one of your Microsoft servers. And so again, that's a client server architecture that right there. So one of the things you might start thinking about is like, well, there's a lot of vulnerability with having one or two Exchange servers. This is a big problem. There's a lot of cost for maintenance and all that. What about if we migrated that up to Office 365? So Office 365 is more, I would argue, more of like a service-oriented architecture type thing. It's a service that's being provided for you. It's a software as a service model. And so that's one thing you may look at and go, instead of upgrading to the next Exchange server, which may cost us, $50,000 in servers, plus all the labor to migrate up to the next version of Exchange Server, why not at that time, why don't we migrate Office over to Office 365 or the Gmail Premium series or something like that to basically get rid of this vulnerability of this server that we have in our environment. So that's one of the things that you can be thinking about. Beyond that, again, when we start thinking about the whole client-server architecture, you can start thinking about things about like, well, where would be the best place to really put a server, right? Having a physical server within your local area network, is that really the wisest way to be providing services to your clients? Possibly simply doing something such as turning your physical server into a virtual machine, turning it into a virtual server, and then running that within a hypervisor within your system, or possibly up on the cloud. That may be a better way to provide services for your end users than what you're currently using. Or even go with a whole metal as a service, where you start thinking about it and go like, well, do I really want to spend all this time and money having our own server room in our environment, or would it be better to migrate the servers that we have up onto the cloud, basically purchase a dedicated server, migrate the services and the data up to a dedicated server, and then figure out how the architecture should be built that way? So these are some of the things to be thinking about with the whole client server architecture. And then as you start going into the future, not just simply, again, because it's legacy, you don't have to upgrade everything. So some of the things you can be thinking about is, well, maybe we should migrate to Office 365. Maybe we should migrate to something else. Then you can be thinking about, should you turn some servers into virtual servers instead of having them as physical servers? Should you move some of the physical servers from your environment up into maybe a co-location facility or rent a dedicated server somewhere? That type of thing. So these are some of the things to be thinking about if you're dealing with a client server architecture and thinking about going into the future with it. So with what I've said, let's go over to the whiteboard for a second. I just want to draw out a couple of examples of ways to be thinking about your client server architecture and how you might want to think about building this going into the future for the modern world. So in the old days, client-server architecture worked very well because more or less everybody was in the same building. Again, for a lot of younger folks out there, you may not realize this, but DSL broadband connection really did not start coming into its own until 2000 or 2001. So most people simply did not have the ability to do things like VPN access into somebody else's LAN. Mobile phones, mobile devices, they really have only come into their own within the last last 10 years. And so basically, if you go back and you look at the architectures and the infrastructures that we were building not that long ago, the idea was everything was in the same building. So you have your servers that are in the building, you have an Active Directory server, you have an email server, you have a file server, and then you have your host computers, your client computers. And on your client computers, you have, let's say, Windows XP installed, and that'll allow you to connect to an Active Directory server. You have Outlook installed, and that will allow you to connect to an email server, and you have the file transfer protocols and all that kind of stuff installed. And so the thing was, why the client server architecture worked so well for so long is because everybody was basically in the same building. So all of your servers were connected more or less to one switch, more or less to one subnet. All of your client computers were more or less connected to the exact same switch, more or less on the exact same subnet. I have to say more or less here because you could get a little bit complicated with routing and all that kind of stuff, but more or less, right? Everything's in the same building, everything's on the same subnet, everything's on the same switch. And so having your systems be able to communicate to the servers was relatively easy. The other thing to think about is basically everybody only had their one computer. So everybody had their one desktop computer, and that is it. So now in the modern world, you have your desktop computer and your laptop computer and your tablet and your phone and your watch and a lot of devices that are synchronizing information back and forth. Well, in the old days, realized that just wasn't the case. Basically, you had your desktop computer and that was it. The other thing is back in the old days, everybody basically use the exact same software. Again, if you were running a server, you were running Microsoft, whether it was NT4 or Windows 2000 or Windows 2003, basically everybody ran the exact same server software. If you had a client computer and you were doing email, more or less everybody used Outlook. So it was a nice, simple, easy to understand, easy to maintain infrastructure where everybody used the exact same crap and everything was on a relatively simple network. And so that's the old world of the client server architecture. Now, as we start moving into the future, let's say it starts getting a little bit more confusing. So we start going to, let's say, the 2005 timeframe. Again, then we have your servers and you have your client computers, and these things are communicating normally like they always do. But then by 2005, remote working becomes a rather normal thing. Now, this is not necessarily even telecommuters the way you think of telecommuters now, but things like on-the-road sales forces. So companies I worked for had a lot of salespeople. They would be out trying to close deals, and so when they are out in the real world, and they're trying to close deals, they need to get email access. They need to get all these things. They need access to the servers within their facility from the outside. And this is where, when you start dealing with this client-server architecture, it starts to get a little bit more complicated. Because remember, you're responsible in this world not just for the servers, but for the servers, for the client computers, the applications installed, plus things like networking, right? So basically, if you have these people that are out on the road, they have to connect to the internet through the ISP, whether it's Verizon or Qwest or AT&T or whatever. And from there, they have to go from the cloud and actually be able to get to your servers. So for this, you have firewall rules to be thinking about. You have routing rules to be thinking about. You have, do you want to have VPN access? So they're going to be communicating with your internal servers using VPN. Are you going to be doing something like port forwarding, right? So even something like an email service. So if you have Outlook, if I have Outlook installed on my client computer and it needs to communicate with the Exchange server in the facility, then not only do I have to worry about Outlook and not only do I have to worry about the Exchange server, but then I have to set up something called a routing and remote access server. So that's a VPN server. So with that, that's the Microsoft's version of virtual private networking. And so then that will give me the tunnel that will then be able to get me into the internal LAN so that I can do things such as email service and file and print sharing and that type of thing. And so this is where, let's say about the 2005 timeframe, the whole client-server architecture starts to become a lot more complicated, because as you have more and more and more and more and more people working outside the main facility, not only do you have to figure out how they can gain access to these servers, but then also you have to worry about hackers, right? So every person you allow access into your local LAN, that is a possible vulnerability where some hacker can come in and try to compromise your systems. And so that's where we start. We start working. That's where you have like the routing and remote access. We start working some other things. Then we get to, let's say, the modern world. So let's say we get to 2015 and beyond. And so now we have the facility. And let's say you have some servers in there. But then one of the problems is even for your internal users, so you have all your internal users, but those internal users, now they have a desktop, and they have a laptop, and they have a tablet, and they have a phone. And so this user may send an email from his phone and then read the response from his desktop computer and then reply to that response from his tablet. And then you have to be thinking about how these different devices are going to be communicating with these servers, right? The desktop computer is going to be communicating internally, but your smartphone, that may be using an LTE connection. So it's actually going out to the cloud and trying to communicate internally. And so this is where things just start to become really complicated. And you have to make sure that all the data amongst all of these devices synchronize, so everything is at the exact same place. And then you have the users that are in the outside world, and you start running into a lot of issues. And so that's where it becomes easier for a lot of people to start using cloud services. Again, so things like Office 365, or Gmail or some of these other things, so they don't have to worry about the routing, they don't have to worry about the firewall, they don't have to worry about the port forwarding, they don't have to worry about all of these devices and possible vulnerabilities. Because that's one thing to be thinking about too. In the old-fashioned LAN, local area network infrastructure with the client-server architecture, is before the IT department had control of everything, right? I owned your computer. I literally owned your computer. Like literally the company owned your system. So I told you what operating system you were going to use. I told you what you were able to install. I put security policies, right? So I was able to lock down your particular computer. And so that was good from a security standpoint. But the problem we get to nowadays is what happens if you have an Android phone. You have an Android phone that you want to be able to communicate with the Office email services, but the company doesn't actually own your Android phone. Your company doesn't actually maintain your Android phone. So what happens if you download malware into your Android phone, you then use a VPN connection to get into the internal network, the internal LAN, and then that malware that you installed starts doing nasty crap to the servers that we have. So these are some of the issues that you start running into with a client-server architecture and things that you need to be thinking about with how do you actually want to build these things out. Again, that's one reason why you might want to do simple things such as move some of your servers just up to the cloud. So Metal as a service, as we talked about before, basically this is where you can rent physical servers in other people's data centers, or again, even just simply go with co-location facilities. So certain things you can start thinking about, even if you're stuck with the client-server architecture, is if you're worried about your LAN, right? You're like, okay, I've got these people in the outside world. They're going to be trying to connect to servers. I'm worried that one of them will have malware or something installed on their system, and then that might compromise my LAN. So one of the things I can think about doing is I can move servers up onto the cloud. So the servers that these people will need access to, I can move them up into the cloud, a co-location facility, Metal as a service, something like that. And then basically I can then try to firewall those servers and segment those servers off from my local area network. So let's say if an email server or a VPN server, an FTP server, something like that gets compromised up in the cloud, then if you have firewalls, if there's a level of separation between your LAN and the cloud infrastructure that you've built, hopefully they won't be able to compromise your internal network. And so these are some of the things just to be thinking about and considering, even if you stay with the client-server architecture, ideas about how can you do things to make that architecture more secure, how can you segment it more, that will be very valuable going into the future as people have more and more and more devices, and trying to control all of those devices becomes ever more complicated. So those are some things to think about with client-server architecture, especially as you start looking at building out a cloud computing infrastructure. You're going to be dealing with client-server architecture, again, because it is legacy, because it was built long before you, and frankly, it'll be around long after you. You can't fight inertia. Inertia will win for the most part. But what you can do is you can try to start moving things into the proper direction. Again, going from Exchange servers up to Office 365, trying to do specific things in order to make your infrastructure work better and possibly cost your company less money, be more secure, so on and so forth. When we're talking about client-server architecture, we're simply talking about the old architecture of you have a client computer, you have the software installed on that client computer, again, something like Outlook, that then is able to communicate back to a physical server that has a server operating system that has a server service installed on it, something like Exchange server. So my Outlook client is able to communicate with my Exchange server. The Exchange server is able to receive emails from the outside world, and then it routes them to my client. When I want to send or respond to emails, I'm able to write that on my client. That then goes to the Exchange server, and the Exchange server is what then routes it out to the outside world. Again, this is a system, an architecture that has been around for a long time, and it works very well in rather simplistic environments. When everybody is more or less in the same building, when everybody is more or less on the same network, that type of thing. When everybody more or less is using one or two possibly devices, a client-server architecture works absolutely great. The problem that you start running into is as you start to have more remote workers, as you have people have more and more devices trying to communicate with your servers, you start running into massive issues with security vulnerabilities. You run into issues about, again, how to route the network traffic. You run into weird issues, again, with ISPs and that type of thing. And that's why client-server architecture at this point in time can become really frustrating. And that's why a lot of people are then moving to cloud services, just because it's just a hell of a lot easier to deal with. Why worry about the CPU fan failing on your Exchange server when you can simply use Office 365 and it's going to keep doing what it's doing? Now, I know some people out there are going to be like, well, Gmail fails every once in a while. I don't know if I can accept Gmail failing or Office 365 going down for a couple of hours. All I'll say with this is with Gmail and Office 365, we see them go down for a couple of hours. You don't see the servers destroying themselves. I've seen Exchange servers go bye-bye. Oops. Oops, you mean multiple drives in your RAID failed at the same time and your backups weren't working properly? Oh well. It's only 5 years of email for every person in the company. That's not really any big deal, right? And so that's the kind of thing to be thinking about. Again, when we start thinking about architectures and infrastructures and all that, do you really want to rely on one system? Does that make you feel comfortable? Do you want to have to deal with the networking and all that kind of stuff that goes along with it? Again, dealing with ports, dealing with routing, all of that type of thing. Because if I have a client computer and that client has a particular IP address, it's on a particular subnet, and then you have the server that might be on a different, obviously has a different IP address, but is on a different subnet, then making sure how one is able to communicate with the other can be a bit frustrating and can run you into some problems. So anyways, that's a brief overview of client-server architecture, some of the things that you need to be thinking about, again, when you start thinking about client computing and as client computing. Cloud computing. When you start thinking about cloud computing. As always, I enjoy doing this video, and I look forward to seeing you in the next one.